Now, any of you that have gone to LSU Theatre or Swine Palace know what great productions they put on. But what you might not know is that they've quietly becoming one of the premier spots for doing science in the theater in the country. And they've just sort of stumbled into this semi-accidentally. It's kind of started with Mike Tick, but it's continued, I think, because both Kristen Sosnowski and George Judy sort of have a strong interest in this area and are often attracted to these kind of plays. And if you look across the types of things that they've produced, if I can turn this on, the types of things that they produced just over the past about a decade. Most recently was Tom Stoppard's Arcadia, which was directed by George Judy, and which deals with elements of chaos theory, the development of entropy theory, and postulates that this young girl here, 16-year-old girl in the mid-1800s, came up with the concept of entropy and fractals before any of the people that we know from the textbooks actually came up with it. So there's a lot of science in that play. Another recent science-y production was Spill, a world premiere here about the BP oil spill by Lee Fondakowski. The set here was reminiscent of a oil rig. There was a lot of discussion of the engineering of the rig, a lot of discussion of exactly what happened during the explosion of the rig in that particular play. One that I'm particularly fond of is Cocktail, just because I was a co-author on it, which was about the development of HIV drug therapies by a woman named Gresdna Chrysintu, which was also another premiere of a science play here at LSU on the Swine Palace stage. Copenhagen by Michael Frayn is probably the most famous or the most successful science play in modern time. I mean, certainly in the past couple of decades. And of course, we've done it here at LSU. This is a picture from the production here at LSU, studio production of it. Another science play that was done here was Frankenstein. Frankenstein, a science play? Isn't it a horror play? Well, this is another one that was directed by George Judy. And the interesting thing about Frankenstein is there's so many different versions of it, and some of the versions really stress this problem of what happens when you have a bad person doing good science. And we have lots of examples of that in the news all the time. The guy who just tried to use did use CRISPR to edit the human genome. Good science, morally problematic, yes. And that's what the problem is in Frankenstein, too. Frankenstein does amazing scientific things in the play, but he's a bad person. And he doesn't do them in a morally perfect way. The Curious Incident of the Dog in the Nighttime also has a fair amount of science element to it. Not only is the lead character autistic, and there's an exploration of the world, how the world looks from his perspective, but he's also interested in different mathematical concepts which are explained in the play. I mean, the play does not gloss over those concepts, but actually tries to develop them. Other recent play is Marjorie Prime, which is an exploration of artificial intelligence and where it might go in the near future. Also, a production was done here of the effects of gamma rays on man-in-the-moon marigolds, which you may have seen in a studio production here. This is not a poster from our studio production here, but this is a poster of an LSU alum. Does anybody know who this LSU alum is that was also in this play? Anybody want to shout it out? No? That's Joanne Woodward. Joanne Woodward is an LSU theater alum, and she did a movie version of this play. And the play has another lead character. It's actually a little girl doing a science project on the effects of radiation on plants, which, oddly enough, you're also going to hear in one of our excerpts today, because that was part of Barbara McClintock's basic research, or original research, was looking at the effects of radiation on plants. Relativity is a play about a mother-daughter conflict, because the daughter is a geneticist and the mother believes in, let's say they are not very scientifically based racial theories, but her mother is very famous and runs institutes and has public talks, and so the mother and daughter in this play sort of conflict over what's acceptable to portray publicly. Do you have to stick to the science, stick to the truth as the daughter wants to, or can you make up your stories as the mother sort of wants to in that play? We did that here too. Another play, A Kind of Alaska, is a Pinter play. That's about the disease encephalitis lethargica, which was first successfully treated with L-DOPA by Oliver Sacks. And this play and the movie Awakenings are both about that. This is not an LSU alum who was in that play, but is one of the most famous actors in that play. Anybody recognize this actress? Yes, Judy Dench. Unfortunately, not an LSU alum, though. Another thing we've done in LSU Theater that Kristen Sosnowski and I have primarily done is do these SciArt conversations, which is what you're seeing right now. A SciArt conversation is, and we've folded it now into the Science Café that the ORED puts on, but what we try to do is we try and get scientists and artists on stage at the same time, talking about a similar topic. So we've done a number of these. Silks was one where we had aerial silks on stage at the same time as someone talking about spider silk. String theory, we've actually done two different versions of string theory where we've actually had a physicist talking about string theory and actually had a string musician playing improvisational compositions. Some of our SciArt conversations have been about specific plays, and so we brought in scientists to react to these plays. But since, in the past decade, we've done about 18 of these. And so that's another thing LSU Theater is doing in a very kind of unique way. So all this has been going on very quietly at LSU Theater. And what we sort of decided to do recently was answer a call for new strategic initiatives in the College of Science and in the university as a whole, to try and solidify this, to try and let the rest of the world know that LSU is putting so much science on stage. And the College of Science has picked us up as one of their new strategic initiatives, the SciArt Initiative. And we've got a set of goals that we're trying to achieve with this new initiative. One of the first two things that we're doing, and that's what you're seeing a preview of tonight, is we're going to have a national conference on science in the theater, and it's going to bring together academics, it's going to bring together practitioners, and it's going to bring together theorists on science in the theater. And as a part of that conference, we're also sponsoring a national new science play festival. And Judy is going to tell you more about that. We did a national solicitation for new science plays, and as part of the conference, we're actually going to do staged readings of several of them. But we have some long-range aims as well. We want to have a SciArt speaker series, which you've also already sort of had one speaker in, and we want to expand beyond theater. Right now, it's primarily theater because Kristen Sosnowski and I, and Judy, who are the major drivers behind it, are all theater associated. But we want to expand this to the entire campus, and it's great that the College of Science and the College of Music and Dramatic Arts are now getting behind this. And when you say getting behind this in academia, that means are putting money into this in order to allow us to grow this and to let the rest of the nation know how much LSU is doing in this area of bringing science and art together. So I'm going to shut up now and let Judy talk to you about the science playwriting contest that we've started and some of the plays that we selected.
We do, in fact, at the College of Music and Dramatic Arts and the School of Theatre, have a passion for interdisciplinary, cross-disciplinary kinds of work. We were privileged to be here at the Science Café when we were producing Arcadia, and one of the sort of great joys of Arcadia was a series that we had just prior to many of our productions, where we brought in people from mathematics, from science, from art, from English, from agriculture, and we believe that the university is a remarkable opportunity to build cross communities for the larger community as a whole, both within the university and without. So we certainly have a passion for this kind of cross-disciplinary work, but in particular, in the School of Theatre, we've enjoyed working on plays that bring together science and art. As Vince was suggesting, we, over the past year, have been reading close to 200 submissions from playwrights around the country. And out of those 200 submissions, which were sort of brought together by the rule that they had to have science not just as a kind of fringe element, but somehow science had to be at the heart of the play. And we've chosen 3 plays that we are, during the SciArts conference next year, hopefully in October, we will bring playwrights in, and for 10 days to 2 weeks, we will begin to workshop their plays. And during the conference, as sort of highlight events scheduled throughout the conference, we'll do minimally staged readings of the 3 winning plays. The first play, we're not going to see scenes from tonight, but I'll tell you just quickly. It's a play by Kristen Adedisak. I hope I pronounced her name correctly. That's called The Surest Poison. It's set in the latter end of the Roaring '20s during the Prohibition era, and it is a musical murder mystery, but at the heart of the murder mystery is the unfolding of forensic chemistry, toxicology, and how that becomes a key component of solving both the mystery and the play, and what at the time was a pretty hot topic. The government was engaged in giving alcohol to marginalized populations in the country that probably wasn't as pure as it should have been. It's a topic that it get addressed in the play in a very theatrical and funny, interesting way. It's inspired by real characters that existed in the end of the Roaring '20s. We're going to see today 2 plays, excerpts from, fairly extended excerpts from 2 plays. The first is Another Revolution, that's written by Jacqueline Bircher, and it is a play that should be familiar to all of us in terms of the relationships. It is 2 young science graduate students, both from very different disciplines, one essentially an ecologist and another a theoretical physicist, who are forced into the same lab space. And you can imagine already that's great drama, right? The play deals with lots of different aspects of science on both of those fronts, from botany to evolution to everything that you can imagine that might be a fringe element in those 2 theories and work in terms of those theories. But the play itself transcends that sort of conflict and begins to be a play about scientists rather than just science. And we see how scientists and all of us, artists as well, begin out of the work that we do to develop a worldview, a way of looking at the world. And frequently we get narrowly defined within the work that we do, so that we lose sight sometimes of worlds that are outside of our own purview. This is a play about those worlds in collision and the humanizing kind of experience that comes from sharing different worldviews. So, Delasha James and Harrison Magner are going to read the scenes for us. The two characters in the play Another Revolution are Kat, who's an ecologist, and Henry, who's a physicist. And this setting of the play is 1968. Those of you who were vividly remembering 1968 are probably too old to be out and about tonight. But that period of time, as you know, was chaos. The Cultural Revolution was really moving in powerful ways. And the two scenes that we're going to see, the first is sort of an introductory scene that throws these two characters together in a lab that really Kat thinks belongs to her. And the second scene is a considerable time later when they come to terms of their different worldviews in the face of a powerful cultural event. So, Another Revolution by Jacqueline Bircher.
Are you okay?
I am wonderful.
You are.
It's an application for the Butler Fellowship. Addressed to me.
Oh, yeah, I got one too.
What? How did you get one?
It came in the mail.
If you're a Butler Fellow, they cover all your expenses for 5 years. Tuition, lab fees, room and board. They don't just hand out applications, you have to qualify.
I'm qualified.
You've only been here for 3 weeks.
I'm really smart.
Okay, Wonder Boy, what are you gonna submit?
Oh, my theory. It's about orbits, galactic orbits. I specialize in orbits.
Like the Earth around the sun.
No, well, yes, but I'm not interested in the Earth. Our solar system is fairly uninteresting.
Right, obviously.
But galactic orbits, now that is interesting. Because planets orbit stars, but stars orbit a galactic center, which is most likely, in the case of our galaxy, a supermassive black hole that emits an intense astronomical radio signal. Galactocentric orbits they're fascinating. And my theory revolves around this thought experiment, which, well, a thought experiment is a theoretical situation and its resulting calculations. The twin paradox, for example, or Schrodinger's cat. And mine is about what would happen, theoretically, if the black hole in the center of our galaxy, or any galaxy for that matter, disappeared. Even though that wouldn't ever happen, but if it did, what would happen? Neat, right?
So, you're not even doing an actual experiment. You're thinking about doing an experiment.
Essentially.
Does that even count as science?
Exploring the laws of physics on a cosmic level aids our understanding of the universe.
But why? You're spending all this time on intergalactic
It's
orbits
galactic,
and
not
black
intergalactic.
holes, but you couldn't say something that's actually relevant to people on Earth.
Intergalactic orbits require a whole other set of calculations to determine the geometry of space-time.
You're an interesting kid, but when I look at this, whatever this is, it makes me think you should be in the math building, not Havenmeyer.
This is science.
Science requires a method: hypothesis, experimentation, observation, conclusion. You're missing a lot of those, I mean. You don't even have a telescope.
You don't need a telescope to study cosmology.
So what do you need, a ruler, a thermometer, a speedometer? You need something.
Just your brain.
That can't be true.
It's an elevated type of theoretical science, logic-based mostly, looking for answers to bigger questions than how long does it take for this seed or that seed to grow.
Is that what you think I'm doing?
Isn't it?
Wow, your head is really far up your ass, you know that?
Excuse me?
What's happening here in this lab that you so gracefully barged in with all your imaginary thought experiments is an actual experiment that will yield measurable results, which will find their way into my very solid and tangible 20-page winning application for the Butler Science Fellowship.
Okay.
A theory. Theories are something you're familiar with, so here's a good one. The global temperature is expected to rise by 1 degree centigrade over the next 50 years. Which doesn't sound like much, but we're talking about very fragile ecosystems, and we just keep pumping carbon dioxide into the atmosphere, so our planet is getting hotter.
I thought it was getting colder.
Absolutely not.
I read that there could be another ice age.
That is dumb, and you shouldn't believe everything you read.
Are you sure? Because it really says...
I'm sure. Now stop interrupting.
Okay.
Plants breathe in CO2, so if there's a lot more CO2 in the atmosphere, what does that mean for phenotypical plant development, nutritional content, ecosystem interactions? This is a life or death situation.
So you're growing plants under different temperatures so you can see how they grow differently?
Exactly.
Well, a middle schooler could do that. It's not very challenging.
Look, in 100 years, everyone's going to be really thankful I was doing this experiment because there will be data, there will be facts, and I will have contributed to them.
It just seems very small.
You know what? I'm sorry I brought it up.
I didn't mean to
No,
insult
it's
you.
fine.
But you don't think you can actually win,
Oh,
do
I
you?
can win.
Has a girl ever won a Butler Fellowship?
Not yet.
I wouldn't get your hopes up.
Wow, that's insulting.
I'm just being honest.
So what are you trying to say? Honestly.
Just that it is unlikely for a girl to win. Statistically,
No,
traditionally...
whatever. You're probably right.
I am right.
Yeah, but that's exactly what everyone told me when I applied to get into this college. And here I am, so screw your universal laws.
Not necessarily.
Yeah, okay.
Newton's first law.
Not again with the Newton. I mean, really.
An object in motion stays in motion at a constant velocity and in the same direction unless acted upon by an outside force. The outside force, it's you. It's a metaphor.
That is weird and strangely nice of you.
Thanks.
But I will crush you, just so we're clear.
I don't really think so, but I guess we'll see.
Then may the best man win.
Columbia University, 1968. We're going to move to a second scene because I want you to feel the move from this competition, which continues, but how it translates into a more human moment for both of them as life continues on a particularly dark day in American history.
How many black people live in Westchester?
I've never noticed.
You tend to notice that sort of thing, especially when people are out murdering each other.
There's nothing we can do about it.
I can't do nothing. I'm wired. I'm electric. I want to burn something.
And what good would that do?
I don't know. Aren't you angry? Aren't you sad?
Sure, it's sad.
I didn't
It's
ask if
very
it was
sad.
sad. I asked if you were sad.
Not really, but it's not like I knew him.
That's bullshit.
He was just one person.
Martin Luther King Jr. was not one person.
Every person is only one person.
Metaphorically,
People die all the time.
someone shot him in the face.
It's very sad. I already said that.
What is wrong with you?
Nothing.
This is important. More important than your stupid calculations.
Not to me.
How can you say that?
You can't force people to care about things. You asked me a question, are you sad? And I told you the truth. No. You don't like my answer, and I'm sorry, I guess. But I don't know how to make myself care about everything because there's too much to care about, and it's too exhausting, and I have too much work to do.
Sometimes I feel really sorry for you. You know that?
Feelings are complicated.
Empathy shouldn't be complicated. It should be intuitive.
It's not as clear as that. Okay. Light is not a particle or a wave. And yet it is both a particle and a wave because the behaviors of light are dependent upon how it is observed and measured.
What does this have to do with
This is-
anything? Oh my God.
This is a basic tenet of quantum theory, wave-particle duality. And in the same way, we can experience sadness and also not because it was a very sad thing. But then Mark Rudd interrupts the memorial service to shout about Columbia mass gentrifying Morningside Heights and mistreating black workers and how we're all complicit in that. So it's both and neither. A logical conundrum, to be sure, which is why I stick to general relativity. Let's you stay out of the whole mess.
You're gonna stay out of it. Just stay out of it? Not engage with other people at all?
That's the current plan.
You're not gonna say anything.
I'm saying that it's sad.
Are you gonna vote?
For what? The president?
Yeah, Bobby Kennedy's running. Are you going to vote for him?
I'm not sure why that's relevant.
Voting is saying something.
Then maybe I won't vote.
That's so stupid.
Why?
Because it hurts people when you say nothing.
I don't think it does, though.
Wow, okay, Henry. Do you ever consider that you live in this world? When you're doing all your interstellar physics, do you ever consider how important this planet is?
Not really.
Wow, that doesn't surprise me.
I don't consider it because we're not important. This planet is microscopic, really. It's not even the largest planet in our solar system. That's Jupiter, 1,200 times the size. And then the sun, you could fit 1.3 million Earths inside of our sun. And it's puny, the runt of the litter as far as stars go. And there are stars billions of times larger and denser than our sun. Blue giants, red supergiants. And every star belongs to a galaxy, which can contain hundreds of billions of stars. And that's just one galaxy. And there are trillions of galaxies, superclusters of galaxies, and across an expanding and possibly infinite universe. And that makes it sound very exciting and crowded, but in reality, it's just a lot of space. Dark, silent, empty space that extends for trillions of light years. And we are nothing but an interesting and unusual but minuscule accident that is entirely insignificant in the vast expanse of space and time.
That is so depressing.
I think it's kind of astonishing.
Here's the thing, though. We're here. We're all here together. And we can't even figure out how to stop fucking killing one another.
Delacia and Harrison, thank you very much. So another revolution, worlds in collision, two very different worldviews, and a lot of science in the play, but also a lot of academe, right? Where we talk about grants and talk about funding, and it is both the bane and the joy of our existence. So we were going to ask Vince to step up again and talk just briefly about a connection to science in the play.
Just very briefly, but I'm supposed to give the science, reaction to it and stuff like that. But yes, we have people in the physics department who are studying black holes in the center of the universe. It's still a controversial question. What is the structural reason for having a supermassive black hole in the center of galaxies? And in 1968, it was a question in its infancy. Katz's reaction to theoretical physics would have been perfectly fine from a biologist in 1968 because now we have lots of theoretical biology. Theoretical biology was also in its infancy in 1968. It was much more experimental biology, which we're going to see some of in the next play as well. So the next segment, these were real science fictional characters. The next segment has as its main characters Barbara McClintock and James Watson. And one of the unusual things about Barbara McClintock, and you'll see a little bit of that in this excerpt, and that's why I wanted to introduce it. She had a very strange scientific career trajectory. She was already famous by about 1944 and in the National Academy of Sciences. And then things sort of derailed because she was so far ahead of the curve. Because what we know today about genetic regulation is that there are regulatory elements that control genes, whether genes get turned on and off. That was not known in the 1940s. And what we also know today about DNA are there are sections of DNA that are called transposons that actually jump around in the genome and go to different places. We didn't know about the regulatory elements really solidly until the 1960s. We didn't know about the transposons really solidly until the 1970s. Barbara McClintock was working on a system that displayed both of these characteristics simultaneously in 1945 and was characterizing them. And people thought she was insane and would not publish her work. And so for about 20 years, she did not publish her work until the 60s and 70s, and people started realizing, all of this work that she had done beforehand on these extraordinarily complex systems.
Yes, I think that's very significant, the science intro, because in fact the play does become inspired from genuine characters that actually historically lived, right? Barbara McClintock, her colleague at Cold Stones Harbor, is that right? Cold Spring Harbor Laboratory. Dr. James Watson is the first character in the first reading that Glenn will be reading, and Christine McMurdo Wallace will be reading Barbara. And around the late 60s, again, Jim Watson had been tasked with taking over these labs, which had sort of fallen out of real, certainly high profile and fame, and his task was to bring them back. And he was going to do that by shifting things to cancer research, which was the hot question on everyone's mind. Barbara was still working at the labs. She had privileges, even though she had essentially retired. And this first scene is about an interaction between Jim Watson and Barbara McClintock. And you'll see the kinds of things that are on the table about what researchers go through, and particularly an iconic female researcher, the kind of world that she lived in and the kind of battles that she had to fight. We're also going to see a second scene with Barbara's colleague, Nina Fedorov, who later in Barbara's life was instrumental in bringing her research back into the public view. Barbara won the Nobel Prize in 1983, and she was the first woman in an unshared category to win the Nobel Prize. So, Cold Springs Harbor Laboratory, around 1968. This is Barbara's lab, essentially, and Jim Watson comes in to connect with her. I would again stress that the playwright makes a great point of saying that these are not the real people, even though they were inspired by them. And my suspicion is that because she takes a dim view of Dr. Watson, I presume.
I'm just here to find out what you've been working on these days. You haven't published anything for a while. I wondered if you'd retired.
Emerita.
Well, you must have been working here for
Since 41. A few years before you hit that baseball into my field.
almost 30 years. Are you still planting those twisty little things you called corn?
Actually, I call it maize. You irradiate it to follow the genetic changes.
I know that, Barb. I know a few things about genetics, about DNA, for example.
I'm finishing up a project tracking the genetic history of maize. We're planning a book.
On history?
You have to understand that maize needs humans to survive, like some kind of pet. No, better, it's like a library made by humans, needing humans, full of endless information.
That's...
Years and years of information. You can trace the migration of people through the migration of the corn plant they brought with them. Ecuador, Bolivia, Chile, Peru, Colombia, Mexico.
That's very interesting, but I came here to talk to you
The
about...
really fascinating part is that in the process of tracking the genetic history of maize, we're learning about how it evolves and how the controlling elements are part of the mutations that have changed the plant over thousands of years.
You're still pushing those controlling elements of yours?
There's no point. People aren't ready to hear what I have to say.
Give them time. The mills of scientists grind slowly.
And they grind us all down.
But they grind extremely fine. Look, I'm sorry, Barbara, but I'm a little pressed for time, and I want to talk to you about my real reason for visiting you.
Okay.
We need a lot more of the genetic tools you've been making all your life. This summer, I'm doing my first symposium as the new director. Most of my research lately has been about cancer, but
I've read it.
I'm bringing the labs back. Prune the dead wood, clean house, choose your metaphor. I'm going to create a clear vision and an efficient system of work.
Instead of a fuzzy vision and an inefficient system of work.
We have to focus on the essential questions. Right now, that's cancer research. Using what we know about DNA to stop this horrible, decaying death. Healing the illnesses and stupidity of the world and putting our labs back on the map.
Swell.
But we need better tools. And I was hoping that you could give up on your corn history and help us develop them.
Just like that.
Oh, okay, yeah, just finish it up and then come work with us. I'll set up some meetings. You don't have to be just a maze geneticist anymore.
Just a maze geneticist?
It'll take you a little bit to get up to speed on our DNA research, but I know you can do it.
Of course I can, but why would I?
I'm going to make Cold Spring Labs the place for cancer research.
Make us all famous.
We're running out of funds, Barb. I've been hired to bring the labs back. To do that, I plan to focus everyone's work on cancer research. And as I said, we need better tools, and you can bring those to the table.
Read my publications. Anything you need is there.
Well, you know, most of them were a long time ago.
Fine. Stick to your molecular biology. Just look at the unrelated bits of material. Don't bother looking at the cell. Don't pay any attention to the whole organism.
Barbara, you need to get to work on some current problems.
You just want to make the laboratory over in your illustrious Nobel-winning image.
You just want to keep reproducing that golden age of corn genetics you had at Cornell. You don't even publish anymore.
I'm not going to waste my time writing papers that no one will read.
Instead of wasting your time doing laundry?
Of course. Doing laundry, pottering around the lab, doing pointless research on maize.
Now, Barb, let's not argue.
I'm not arguing. I'm saying no.
Well, now they say that no is just a step towards yes.
Yeah, gee. And I always thought it was a step toward no.
I've got another meeting right now, but I know we'll find a way to work together.
Goodbye, Jim.
Atta girl. I'll drop in on you whenever I'm by here again.
Atta girl? Atta girl.
Barbara was also notable. Yes, thank you, Glenn and Christine. Barbara was also notable in some ways for her own self-sabotage. She was having a real conversation with herself about whether her work would be acknowledged in the way she wanted it to be acknowledged, and she didn't want to move to a new front without, I think, meeting the needs of what she saw as her own research. And the way that sort of opened up again for her was her connection with a young embryologist, Nina Fedorov, who became a plant geneticist, and Barbara had been able to resist Jim Watson's overtures for a long time, but Nina finally found a way in to begin to make inroads in opening Barbara back up to the more current events of the world. So this is probably 4 years later than the scene that you just saw before.
You can't possibly learn enough about maize at this point.
I read all your papers.
No one has read all my papers.
They're complex, of course. They deal with complex ideas, but they're also clear and logical and beautiful.
Don't try to flatter me, young woman. We have a nice chat, and a couple of years later, you suddenly want to be a plant geneticist?
I am a plant geneticist now. It took me 4 years, but I'm doing plant research at the Carnegie in Washington.
It's still molecular biology, tiny bits of stuff, not the whole plant.
Then help me to understand the whole plant.
I don't have time to be a teacher.
You know, they discovered that DNA actually causes and controls mutation. But no one has ever followed up with maize.
Oh, that's a terrible word. Controls. What a wacky idea that was. No wonder no one listened to me.
But it isn't wacky. It's obvious. DNA is like a language that controls genetic information. Polymerase enzymes transcribe it into RNA
Yes,
language.
I know all about it. It's a complicated system.
It is. It's a lot more complicated than anyone has ever seen. I want to look into what really controls
No one wants to hear about controlling elements.
Okay. But if we clone some maize genes, I can isolate one of your transposable elements physically. People will be able to see it. That will show them how DNA and RNA control heredity. All I want for you is to teach me how to plant and pollinate maize plants.
It's not easy.
I'm not looking for easy. I'm looking for something I really want to do, not just something my advisors told me I have to do.
You have to control pollination. That means tagging every plant. It means hand pollinating, so you know that your crosses are accurate. That means tagging every single ear, hundreds of thousands of ears. You'll work from dawn till midnight, all summer.
I need the exercise.
I don't.
Barbara, you're way out ahead of them with the notion that there are genetic elements separate from genes. I want to figure out how your jumping genes operate on the molecular level.
Transposons. Jumping genes is for the tabloids.
Okay, transposons. I want to research how they work on the molecular...
I've got too much to do. Find someone else.
You're the best there is.
No is not a step toward yes.
What? Okay. What about this? Everyone is worried about population growth.
That guy who wrote the population bomb, right? A few years ago? One of those 60s radicals.
He overstated the case, but it's still a problem. With too many people, the land wears out from overplanting. We need to change the crops, make them grow in places they don't grow now, increase the protein in grains.
Getting me on the old humanitarian argument.
Plants have to adapt and mutate because they can't run away from dangers the way animals do. But people can't run away from these problems anymore.
I've watched them do it for years.
With the techniques of molecular biology, we can learn how genes are controlled. And they are. Maybe not the way you thought, but there is some kind of mechanism at work. And I want to find it and use it to grow better crops.
Feed the world.
You think that's stupid?
No, always the noble motives.
I'm not being noble. I'm just fascinated with maize. Surely you can find time to meet with me once or twice?
No.
Just think about it.
Don't be difficult, young woman.
I don't mean to be difficult, Dr. McClintock. I just...
Thank you both. Christine and Delacia.